Okay. So once again, good morning to everyone. So my name is Devashish Biswal and I am looking after the pre-sales activity in India. So today's session is basically on machine verification, which is very popular among the manufacturing field. So the milling machine which had the touch probe, so we can use the touch probe for verification on the machine itself. So that's called on machine verification. And through on machine verification also you can automate your process. So through today's session we'll go through the process and how OMV works, right? So topic will be like this. So first we'll discuss what is OMV and why it's necessary. Then we'll discuss some vital features inside OMV. Then how to generate the probe path and how to simulate your tool paths. Okay, so how to simulate your probe path. Then what kind of post processor you will need. Okay, so like your milling software, this OMB application needs post processor. So this is the same format which is widely used in inside PowerMill. So inside PowerMill we are basically using the PM OPTZ format. So inside OMB also the same format will be applicable, but instead of milling applications, we'll see some macro functionality for inspection. Okay, so that thing will be included inside post. So through that post we'll generate the NC file, and that NC file will be run on the machine, and after that we can import that result from the machine and generate the report. So this will be our topics, and after that we'll have a brief overview of adaptive software fixturing, which is basically the automation part. So in most of the cases, all of the milling applications inside milling application, we need to align the component, right? So you need to dial the component through X or Y. Okay, and it takes a lot of time. It's a time consumable activity, and it need a skill manpower. To avoid that, so you can use this adaptive software fixturing part. So this is also included inside PowerInspect OMV functionality. So that we'll look into it. So now we'll discuss on types of OMV. So what kind of CNC CMM are available? So that's I'm going to cover.
You can find CMM two types. Okay, one is manual CMM, which cost is lesser, much more lesser, and one kind of CNC uses your CNC mode that is fully automated. So this kind of CNC machine is very widely used inside the manufacturing segment. So though some softwares was pre-bundled with the machine, but you can approach the PowerInspect CNC CMM software along with the machine. If someone is interested, then you can supply this software also. Then I will give you a basic overview what is the CNC CMM. Going through the video. So just I'm going to.
You tell the machine to start taking measurements. Running your program in PowerInspect can be done with a click of a button. By By switching to Run Program mode, you can immediately tell the machine to start taking measurements. You're also given the ability to pause or stop the machine from within PowerInspect. PowerInspect warns you if the start range is not at the beginning of your list of geometries. But this is fine for this case. In the top left corner, you can see the real-life measurements being taken, as well as a virtual representation of the machine in PowerInspect.
So here you can see one thing. Inside the CNC CMM, if you have the Renishaw PH10 probe, you can do the 3-axis inspection as well as 5-axis positional inspection. Okay.
After this, we can display the labels to show the areas that have been inspected.
So this is the way you can inspect your component inside the CNC CMM. And here, one thing you can remember, always your software to be online, to be connected with your CNC CMM for the inspection, right? And apart from that, the CNC programming technique, if you want to generate the inspection sequence, or you have to create the geometric inspection or surface inspection, the same method is applicable on OMV also. Programming point of view, the generation of the features, generation of the inspection points are very similar. Okay, nothing is difference between the both application, but here your software to be continuously connected with the machine for the inspection, and in other hand, in OMB your software will generate the NC code and it will be run on the machine. So these are the two basic differences between this CNC CMM and OMB. So I have to just give a overview on this CMM CNC types. Then what is OMB? So if you talk about the OMB, on machine verification, it's simple logic that if you have any VMC machine like VMC or HMC, okay, and you don't have to remove the part for the inspection to CNC inspection section. So it can be inspection on the machine itself, right? So if you have the VMC machine or HMC machine, you need to attach a touch probe. So if you consider about the touch probe, you can see here the Renishaw is delivering the touch probes, Marcos is delivering, and Blum has the this touch probe option. But if you go to the inspection segment, in all of the machines nowadays, this touch probe is available. So just don't misinterpret like you have if this touch probe that machine have, then it can be worked with the OMB application. It's not like that. So you have to first confirm that the OMB application is installed on that machine itself or not, because the touch probe is usually attached on the machine for the center finding process. Okay, so in most of the machines, manufacturer decided to take this probe to find out the center, but it's not exactly that if you supply this OMV PowerInspect software, it will work along with that Touch Pro. So machine people has to provide another option, that is the cost option, that software should be incorporated with that machine. Okay, so what is OMV? Just I am going to make a small overview on that. If this kind of electrode is machine on the VMC, then after machining, if you want to check the electrode sizes and thickness, then you can do that. Got the basic overview of the OMV, right? So when you are going to your prospect or customer, so first identify whether this on machine verification software, it means that to be installed their controller. Okay, if they have the hash machine, then and if they have the Renisor touch probe, then this inspection software, that is the inbuilt software of Renisor, to be installed on the machine controller itself. So I want to differentiate the CNC CMM and OMV in this slide. So what is the basic differences? So in CNC CMM, it can measure 3-axis and 5-axis feature on a same machine. Okay, so if you have the OMV application, then and if you want to inspect one 5-axis positional feature, then you need a multi-axis machine. But in CNC CMM, you can measure with a probe. So it is the basic difference. Then CNC CMM works online. It means you need a PowerInspect license always to be connected with the CMM. And in OMV case, it works offline. It means one PowerInspect sheet, you can control a number of machine. And if you consider the CNC CMM, it's more accurate, while OMB is less accurate, because there are a certain application of like a heavy roughing and finishing operation to be work on the machine, and the same spindle is used for the inspection purpose, then some accuracy will be loose. Then inspection time on the CNC CMM will be higher in case of CAM and CMM workflow. So if you have to inspect the component after the machining work, after the CAM work, then you have to move that part from the machine to CNC CMM. Then some rectification will be done. Then you have to again move that part to the machine itself. Okay, so it is much more time consuming activity, while on OMB it takes less time, that you don't need to move the object from the machine for inspection. So this is a very good point while you are going to convince prospect for the OMB. Then in CNC CMM, investment cost is much more higher, and for the OMB its investment cost is very less. Okay, so this is the key features of the PowerInspect, like I previously described. The job setup time is very less. Then it has a basic extensive CAD compatibility. You can import any kind of CAD data. It's offline. It supports all types of mainstream machine controllers like Siemens, Head and Hand, Fanuc, and it supports all 3D touch trigger type like Reniso, Marcos, Blum, and it has the simple programming method for up to 5-axis machine. Then auto collision option is there to make ensure your probe to be always safe, and it has a customizable reporting format which is very easy to understand and easy to customize. Going further, like I said before, it has a wide range of post-processor availability up to 5 axes. Then it has a auto collision checking option, and it has a clear reporting format. Like you can see, you can add the CAD view image with this labeling option, and here you can put the graph, and it is a very clear reporting format. Then what is the probe setup and calibration? If we talk about the calibration is a very common language in inspection. Okay, so if you are using the CNC CMM or manual CMM or OMV application, the probe which you are using must be calibrated. Okay, why calibration is more needed? Through the calibration process, you can ensure the accuracy of the inspection. Okay, so without calibration, you can't rely on the inspection result. So I'm just going to take an overview on the calibration process inside the PowerInspect software. And a calibration process will be different from module to module. If you have PowerInspect CMM, CNC module, and if you have a PowerInspect manual module, okay. So in both of the cases, the calibration process will be different. So just take a look, and you can easily understand why this calibration needed and how it can be done with the PowerInspect software.
Probe setup and calibration is a very important factor in achieving accurate and reliable results. In this tutorial, we will create a probe head and stylus for a CNC CMM, as well as a machine tool when using on-machine verification. We'll also show you how to change the probe when using a manual device and ensure it is calibrated accurately to get the very best results. On screen, we already have a model imported, and I can see that I require a different probe diameter in order to inspect all the geometric features on this part. Based on previous inspections, I know that this geometric feature is smaller in diameter and thus needs a smaller probe. We need to not only create a smaller probe, but also make sure it is calibrated accurately. Probe creation for CNC CMMs and machine tools in PowerInspect is done by navigating to the Machine tab and selecting the correct probe head from the extensive list available. Now I need to add the relevant probe sub-assemblies to match the physical probe hardware I currently have on my machine. To do this, on the probe menu click New and specify the module, any extensions, and stylus so that my current simulator hardware matches that hardware used on the machine. Probe calibration on CMMs and manual devices as well as machine tools can be done in a multitude of different ways. This can be done from within PowerInspect or can be done directly in the protocol if doing calibration independently. This is usually the case when using the I++ protocol on that of CMMs. Calibration for CMMs in PowerInspect is done using the simple probe calibration wizard. This process ensures all necessary probe angles are calibrated before the inspection is carried out. Probe calibration for machine tools can either be done on the controller or from within PowerInspect. It should be noted that most controller calibration cycles are performed using two-dimensional calibration. However, PowerInspect's PI Calibrate add-in utilizes three-dimensional calibration to ensure the results are more accurate for three-dimensional multi-axis measurements. When it comes to manual measuring, firstly, make sure that the correct protocol is selected, then navigate to the Tools tab and select the correct probe or laser scanner required. I can then go ahead and change this physically on the device as well. Please refer to either the help menu located inside PowerInspect, the Autodesk Knowledge Network, or other tutorials for further guidance.
So I think you got the basic overview of why this calibration needed. So let's go through the technical demonstration. While going through the technical demonstration of OMV on machine verification, I want to ensure you some stages. Okay, so how PowerInspect OMV works. So it basically works on 3 stages. Okay, so let me show you. So here you can see there are 3 stages. Okay, so first one is creating the probe path and simulation. Second one is exporting the NC code and running it on the machine. And third one is importing the results and reading the report. So these are some 3 stages. And in first stage, I will show you these points. Okay. So in first stage, we'll see how to import and managing the CAD. Then how to import the CAD model of the machine inside the software, then how to set up the probe, how to make the inspection sequence, then how to edit your probe path, then how to simulate it. So this is my agenda for the technical demonstration. So I'm just moving to my software. So this is your PowerInspect Ultimate OMV 2020. So first you can see there is a Marpos T25G probe is available, and this while describing here, I am going to ensure you the mouse movement and all of the functionalities will be remain same, like if you know Power Mill or Power Shape. Okay, so this is the top view, front view, side view. All of the control can be customized by the keyboard shortcut, like Control+5 is the top view. Okay, and later on, if you move to further, then you can go to the machine, and inside the machine you can add the machine model. Okay, go to the change model, and here you can open the mtd file. If you have the PowerInspect OMV module for 3-axis machine, then you don't need for those this mtd file, because this mtd file, the CAD model of the machine, is mainly available, mainly beneficial for your 5-axis simulation, 5-axis inspection. Okay, if you have the 3-axis inspection sequence, then you don't need this machine model. So just it's for demonstration purpose. I am just going to show you how it looks inside the software. So select the mtd file, click on open, and here you can see the 3D model of the machine is displaying. Then if you have to select the probe assembly, here the default probe assembly is Marpos. If you want to change it, then you can select any of the probe, touch probe from here. And if you have to do the probe assembly, now I have selected the probe assembly of Marpos, and you can click on new, and you can select any of the stylus or extension. Suppose you want to make it extension of just like here, you can extend the add the extension, and apart from that you can add the stylus also. If you want to add the stylus of 30 mm, then you can add it. So this is the way you can add the probe assembly inside the software. So apart from that, if you go to the machine, you can find there is a simulation parameter. It is very important factor. So while keeping it on 100, then your simulation speed will be much more faster. If you make it some lower percentage, then simulation will be slower. Okay, and apart from that, if you go for the moving this probe, then you can use in this home tab, you can use this move probe to up and down of the probe. Understood? Then after clicking on that, you have to deactivate this option. Then go to sequence tree, and in sequence tree you can add the CAD model. Go to the CAD model, just add it. Just I have a demo block modified DDJ format, and here you can add any of the CAD model. Just I am going to show you. Here there is a lot of CAD format available inside the software, so we can import the direct file of any of the software. Like if you you have the CATIA file, if you have the Pro file, you can directly import the native file. You don't need to convert that into IGS step or Parasolid. So while importing that model, you can see model is inside the bed. Okay, so now you have to go for the PCS CAD atom, right? Then right click on here and go to click on auto position. So after clicking on that, you can find out that model will be moved upside. And I have previously set the X0, Y0 and Z0 on the top portion, top 0 of the component. And here you can see there is a vice which is in different blue color, and this is one gray color. So we can manipulate these things inside this CAD, and here you can find the different layers. Okay, so now if you don't need to if you have to work on this component only, then you should tick off the level, right? It will be displayed, but the raster toolpath and all which will be applicable on this component only. If you click on this level, then if you generate the inspection sequence, this part will also be calculated. So if you don't want to calculate that, so just deactivate this tick mark over here. It will be just only displayed. So moving forward, go to sequence tree. Then you can find one option here that is called as target point. So just I'm going to move my probe to 200 mm away in Z position, Z location, right? So here this is my 0 position, and I want to keep my probe 200 mm up in Z direction. So what I can do, just give here 200 mm and click on the go to target point. So what it will be done, then you can see this is a 200 mm distance set on the machine. So if you don't want machine displayed over the screen, then you can hide this machine by clicking on view icon. Just click on view icon, and here you can hide or unhide the machine. You will find only the probe and component. So first we'll see what are the basic options. Okay, like I described you before, that in inspection software alignment is the must. But while you are using this OMV application, and this component is already fixed on your machine, and you are doing any cam sequence, like you have just finished the cam application on this component, and you want to measure the geometry feature, then you don't need the alignment because it's already aligned on the machine. So now you have to generate the geometric fixtures only. So how to create the geometry features? So for geometry features, you have to use this wireframe checker. So this is the option in geometry tab. While clicking on here and right click on the screen, you can find several options will be popped up. First one is surface, second one is wireframe, simple wireframe, points, GD&T. So we can, if you have to select the plane functionalities over this flat surface, then you can directly select the surface, and while clicking on here, what software will do, software will automatically extract the nominal value of this surface, which will be converted to the plane functionalities. If you go to the plane, just I am going to right click, modify, and you can see here the centroid, the XY direction, IJK, this vector, all of the things is automatically extracted from the CAD model. Okay, so now I have to only define the inspection sequence. So I have just put the 3 points, this is the 4 points, and here you can set your retract distance. Just give the retract distance as 25 mm and click on save the feature. So in this way, you can generate the geometric feature. This plane, circle, slot, cylinder, sphere, these all are geometric features. Okay. So to create the geometric features, you need this wireframe checker functionalities. Then if I need to check the circle over here, then what you can do, just right click, go for the simple wireframe. While clicking on simple wireframe, just click on the edge. So here what you can do, just go to Geometric Explorer. Inside the Geometry Explorer, you can set the plane 1 as a reference plane. So circle 1 will be project on plane 1, correct? Then you can go here in feature. So just you can see there are 6 points to be taken as inspection point. So I'm just going to reduce that. How to reduce? Just go to parameter, go to points, and load the point to 4, and you can accept it. So in this way, you can generate your geometric features, which is very easy to extract. So like you can see, there are 2 geometric features, 1 plane has been generated. So moving further, if you want to make the inspection sequence, okay, you want to check it whether how to simulate the results. Okay, so go to run, and here you can click on the run all items. So while clicking on here, your probe will do the dry run, and it will show you whether some accidents or some collision happens between the inspection sequence that can be easily identified by this simulate program. So this is the basic sequence we have created for the geometric feature. So now moving further, I'm going to check some inspection points. So how to check the inspection point? Go to home bar, home tab. So inside form toolbar, you can see for a form option, you can find the CNC surface group. So click on here. After clicking, you can see, you can define the points, whether it will be flat surface or 3D surface. You can easily make your points, and you can move it where you have to set it. So after clicking here, you can set the retract distance and click on tick. And then if you want to simulate this inspection points only, then right click and go to start range, and you can easily dry run your probe here. So in this way, you can generate the inspection sequence. Then if I have to do the inspection on a particular surface, then how to do that? Just I am moving forward. If I have a particular surface, I am going to delete it. Go to form, click on CNC surface group. And here you can find an option called as selected surface. Just I'm making it much more zoom. See, there is an option called selected surface. So selected surface is applicable on a single surface. So click on here. Now it's showing no surface selected to generate a probe path. So how to select the surface? Go to parameter. Inside the parameter, you can find there is an option called select the surface graphically. Then you can select any of the surface. I'm just going to select the top face. Click on accept. And here you have to click on select. Then you can see there is an inspection sequence automatically generated on the selected surface. And the sequence can be changed. Like you can see, there is a points, inspection points come on the edges, okay, in this side and this side. So if you want to change the limit, okay, change the inspection area, then you can do it also by clicking the parameter, going here by normalized units, click on the limit. So just I'm putting the limit of 0.05 and will be 0.95. And here the pattern direction is U, and you can set as U or V. Okay, U means in horizontal direction, V means vertical direction. Just click on here and you can see so inspection sequence automatically move. So to modify it, you can clicking on here. So in this way, you can do the inspection on a particular surface. And apart from that, you can inspect any of the selected surface on the component. So just I'm going to delete it. So now I'm going to inspect all of the component. Okay, so can I generate a raster probing toolpath on the component? So how to do that? Just go to inspection sequence, go to CNC surface group, and here you can find the raster option is available. So go and select that, and you can see the raster options is automatically generated the inspection sequence on this particular part. If I want to change the area, the limit the area in Power Mill, we usually know there is a boundary option. So here there is a limit option available. So by specifying the limits, you can set the area, inspection area. Okay, so you can change it from here X, Y, Z, or else you can use your graphic method to set the area. So in this way, you can manipulate the areas to be inspected. Apart from that, if I want to inspect this side face, Okay. Can I generate the raster probing method on the side edges? Yes, you can do that. So how to do that? Just go to the parameter. So here another option you can find. There is an option called edit projection direction. So click on here, and here there is a rotation option available. Just go on, click on rotation and rotate around y-axis. If I have to project on this x-axis, then you have to rotate through y-axis, and you have to rotate the zx plane to be projected on this side. So go and select -90, click on OK. If you click on tick, then you can see the inspection sequence has been moved to this side. So apart from that, if you go for inspection of the another side, what you can do, go to edit project direction and just edit it by clicking on 90°. You can set your inspection sequence, move to different side. So in this way, you can generate the raster probing method for all of your sites. So this is the one kind of process to generate the raster probing method. Then if we have to create the raster toolpath on this surface, so just I'm going to click on this surface selector, and you can see there are multiple surface on this top face. Okay, so if I have to generate the raster toolpath on this particular segment, this particular island, so how to do that? For that, you need to select these surfaces by this option, surface selector. Now what you can do, just right click, go to group surfaces. While clicking on group surface, click on create new level. I'm clicking on giving some new name, island. And while clicking on create new level, so there are two levels already generated along with the CAD component. So one is general, another one is wireframe. I've just created another new level called island and click on OK. And if you go through the CAD, and you can see there is a new layer has been generated by the name of island. So take off this wireframe because you have to work on this island level only. So now what you can do, go to this CNC surface group, and here you can go for the raster. While clicking on raster, see the raster is only applicable on the selected level, because in the parameter there is an option called from selected CAD level is activated. So while this option is activated, so whatever your layer is activated here, so here you can see only island level is activated. Okay, so when the layer is activated here, the PowerInspect is going to generate the inspection sequence or probe to path on that particular layer. So this is one tips and tricks, and later on we'll move to dynamic sectioning. So this is the important factor. If you have to check the section, then how to do that. So moving forward, I'm just going to make on tick here. So here in form, you can find the CNC section group. While clicking on here, I'm just going to deactivate this CAD model. Okay, so now here my section group is available. So this is sectioning through x-axis. So how to modify that? Just right click, go to modify item, and here you can see I'm going to select the top view. So the x-axis has been sectioning, so the coordinate of 0, and if you put the 20 mm, then here will be sectioning happens. Okay, so in this way you can create the section on the particular axis. Okay, apart from the x-axis, if you choose the y-axis, then it will generate the section on the particular axis. Apart from that, if you want to section on a particular user-defined plane, what you can do, just go to the pick plane and you can define one particular plane, and here your section will be done. While clicking on this sectioning, just click on OK, and it will automatically, and if you set on the raster, it will automatically generate the probe path on the particular section. Clear? Apart from that, if I want to generate one sectioning on a particular datum, I can do that. So how to do that? Just you can see there is this is the default CAD datum of the component. Okay, and if I have to generate another datum, so how to generate that? So go to alignment and datum, and here you can find there is an option called rotated datum. So I want to create another coordinate system by rotating this datum by 45 degree around Z axis. So how to do that? Go to rotated datum, and this you can rename it new datum, and rotation axis is Z axis, rotation angle is 45 degree, and which datum I want to modify, just the PCS CAD datum, and click on OK. So you can find there is another datum was generated, right? And after generating this new datum, go to Home tab, go to CNC section group, and here you can right click, modify. After clicking on modify, see there is no changes in the sectioning, right? I want to use this new datum. So how to do that? Just go to the coordinate system and select the new datum. After selecting here, you can set your x-axis, y or z-axis. So you can see. So this is the new x-axis defined for the new datum. So here you can put the coordinate, and here will be your new sectioning group. So in this way, you can generate the inspection sequence on a particular section. So this is very simple. Then we'll move further. I'm going to delete it. So just I'm going to make another sequence, CNC surface group, and okay. So now I'm going to delete these points. Just I'm going to select another. Right. Go to select, and I'm going to Just 1 minute. Yeah, I have to go for the optimal, then I can delete these points. Yeah. So now I can put whatever the inspection point. So now what I can do, I'm just going to put some point over this surface and right. So now what is my objective? I want to move the pro path, edit the pro path. So this is my default pro path which I have generated here. So by clicking the several points, I have generated the default probe sequence. So just this is the 229 number point. Because why this number is fluctuating, because I already generated the inspection sequence before. So what PowerInspect does, if you created the inspection sequence before, then it will it remember the point number and it further generate the the next sequence number automatically. So how to modify that into the surface number point number 1 and up to point number 5? Just go to one minute. I'm creating the sequence again. After clicking on here, you have to accept here. Then how to do that? Just right click, modify. So here you can find the counter level is 239. Just put it 1 and incremental as 1 and update existing points. So what you can find, just SP1 to SP5. Okay. So how we can denote here? Just go to view and go to geometry form, and here you can find this is my point number 1, this is point number 5. Okay, if I want to move the sequence from point number 1 to point number 5, so what I can do, I can easily manipulate the points from up to down, down to up. Okay, now you can see the inspection sequence has been changed. So this is the way you can change the sequence. So apart from that, if you have to generate the point between this point number 2 and 3, if I want to generate the another point, what you can do, you can generate another point here. How? Just go to edit, and here you can select this link. So link will be turned as blue color dotted line. So what you can do, just click on control button and just double click on the particular surface or face. So now you can find there is another point has been added in between point number 2 and point number 3. So this is the method of creation of inserting the points between the inspection sequence. And apart from that, if you want to split, see there is a collision happening here. Okay, if I want to split this point, how to do that? Just go to wireframe mode, and what you can do, just right click over there and click on split. While clicking on split, you can find it has been splitted to the point, and you can easily move to the outside, right? And you can freely move it in X, Y, and Z direction. Suppose I need to move in particular direction. Suppose I want to move it only in Z direction. So how to do that? Just click on Z on the keyboard and just drag this button. Okay, so it will only move into the Z direction. And click on the X on the keyboard of your system and move it. It will only move on the X direction. And you click on the Y and move it, so it will only move on the y direction. So this is the way to control your pro path, correct? So now what you can do, just I am going to delete it. So see, there is already it has been there is a collision happening here. So to avoid this collision, what I can do, either I can split it or I can put a breakage point normal to this geometry. Okay, how to do that? So just click on Control and Shift button and selecting this link, double click on the particular surface. So what it will do, it will add one more point, okay, and it will split it into the two parts, and you can easily make a easy distance, safe distance between these 2 points. Okay, so in this way you can generate or add a split points between this inspection sequence. So how to do that? Just go and select this link, click Control and Shift button on the keyboard and click on the particular surface on which you want to make a safe distance. So it will add one more safe distance. So now what you can do, you can do the height adjustment here and you can move it further. In this way, you can make a safe distance for your inspection sequence. Apart from that, so this is my inspection sequence, and here you can see there is a collision happening. So now what I can do, I can do one thing, just go to edit, select in this link, go to Control and Shift button, just click over there, and you can find there is no collision. Okay, so now what I can do, this is my first link, first inspection sequence, and later on I'm going to make another sequence for this circle or this plane. So what I can do, just go to geometry, go to wireframe checker, right click and go to surface, just click over here or just go to here, right click, surface, clear. So what happen if you come out from this feature, you can see if you play these two sequence, what happen, it will show some error. Okay, so how to identify that? I'm just going to delete it and I'm going to make an inspection. This is my start range and this is my end range. So I have to on the layer, you can see, okay, so it will foul. Actually I have taken the point very downside so that my stylus will hit on the component, so I have to move it. Just go to the plane 3, edit it and move it further. Okay, so click on take. So now what happened, I'm just going to make a simulation. Go to run and click on simulation. So see what happened. So it has been detected the collision, okay, and if you ignore it, then it will come this side. But while moving from this inspection sequence to this geometric inspection, then there is a collision happening. So how to avoid that? So PowerInspect has the unique auto avoid option to change the to keep the probe safe from this collision. So how to do that? Just go outside and click on auto avoid. So it will automatically arrange one intermediate path between these two sequences. So see here, there is a intermediate path automatically added between these two sequences. So just moving forward, I'm moving this probe and go to inspection sequence again and click on play. See, there is a auto link has been added inside the two sequence. So in this way, you can generate the probe path, edit the probe path, and you can use the auto collision checking feature. So moving to the slide. So here we almost cover all the points. So how to create probe path and simulation. So if this stage is covered, then next stage is how to generate the NC program. So how to generate the NC program? So this is a small video, just I want to show you. So see here, we have already generated the sequence. Then go to NC program, click on the NC program output. Then the CL data and the NC program will save. Just you can set the post processor, whether it's a 3-axis or 5-axis. And you have to select the location where NC program will save. And here you have to give the name. Click on save and click on OK, and your NC program will be generated. So it is different from the normal CAM program, and after opening it, you can see a number of macro programming is mentioning here. So this NC program to be run on the component. So this is the on-job inspection. Okay. So now probe is taking points with the inspection sequence you generated inside the software. So this is the second stage. So after creating the probe path, you need to simulate it and you need to generate the NC file. So after generating the NC file and running it on the machine, so machine will generate a NC code itself. Okay. And that NC code to be transferred to the operator who is using your PowerInspect software. So that may be a DAT file or any kind of file format which has been received from the machine. So let's see. So this is my stage 3. So in stage 3, you can see here importing the results. Importing the results means you have to import the results from the machine. After running the NC program on the machine, you will get a DAT file. Just remember it. You will get a file from the machine, and that file has to be compiled with your existing CAD nominal, and after that you can generate the report. So just see it how we can do it inside the software. So here inside the NC program tab, just configure import, and here you have to import that file. This is the DAT file which you received from the machine, and here you have to select the CL data file, that is the cutter location file. This is the default script file. After that, you need to compile it, rerun it. So just see 61 points calculated, and go for the report. And inside the report, you can find what is the deviation and all. So this is the default format, and you can add the CAD view of this report by clicking the CAD view report template. So now you can see one CAD view image will automatically added. So this is the default way to inspect on OMV. And like I said before, during the session 1, we can generate this report through Excel template or HTML template, and from the HTML template you can generate the report through PDF format. So in this way you can generate the report.
So through this process, we already know about how OMV works. So now we are moving to another functionality that is called as automation part. So in PowerInspect, we have got one dedicated feature called as adaptive software fixturing. So what does it mean and how it will help customer to reduce their cycle time, to reduce their effort and increase their productivity? So what are the common issues we face during the machining process? So during the machining process, whether in case of fresh job dialing, or we need to align the job for rework process, we need the dialing process, right? So we need to find out the center and we need to straighten the job. Okay, so that is a hectic task and it's a time consuming activity, and which need a skilled manpower, and sometime because of this we fail to meet delivery schedule. So what is the solution, and what Autodesk PowerInspect will help you? Okay, so let's see one video. So in this video, I will show you what is the manual setup and what is the automated setup. So you can differentiate between these two setups. Just have a look. You got the basic idea why automation needed and how Autodesk PowerInspect will help customer to reduce their cycle time, to reduce their process time, right? So what option we have inside PowerInspect? So that's adaptive software fixturing. So how adaptive software fixturing works? So just let have a look. So what is adaptive software fixturing? So it is basically a process inside PowerInspect to align the part to optimize the machining process. So through adaptive software fixturing, you can inspect part to determine its true form, location, and orientation. So it will generate a new datum which can be transferred to the CAM software. So might have the customer both of the software will be available, just like PowerMill and PowerInspect. So if both of the software will available, then this adaptive software fixturing work perfectly. So what PowerInspect does? PowerInspect will generate a new datum according to the true location and true orientation of the part. Okay, and that new datum can be transferred directly to the PowerMill. So how this new datum will be created? So you can take certain points, and by taking certain points in PowerInspect, you can create a best fit alignment. Through best fit alignment, you can create a new datum, and that new datum can be transferred directly to the PowerMill. So this is the process, and what kind of applications will be covered through this adaptive software fixturing. So you can use it for like remanufactured part, just like casting, fabrication, forging, freeform part, composites. Okay, so all of this application can be covered through this adaptive software fixturing. So how it works? So first, you need to determine the machining datum and inspection datum. So that's the first one. Then you have to set a rough machining datum on the machine itself, and you need to create a PowerInspect session. Then you need to execute the inspection program, which was created inside PowerInspect. So through PowerInspect, you can generate a NC program, and that to be run on the machine. Then you need to get some result from the inspection on the machine. So while running the NC file, you will generate machine will generate some file. So that will be the result. So that result to be again imported inside PowerInspect, and you can create a best fit alignment, and through best fit alignment you can generate a new datum. Okay, and that new datum which is called as delta to be exported your CAM application. So the CAM application might be the PowerMill. Okay, so PowerMill will be if customer has PowerMill, that will be good. Then you can create the milling program or milling toolpaths using that new datum. Okay, and you can run toolpath on the machine. So this is the whole process how adaptive software fixturing works. So I have a small video through which I can take you through the process. Just have a look.
Our customers' designs are continually evolving, using new materials and construction methods. This brings many benefits, but can also add to the technical challenges they face throughout the manufacturing process. At Autodesk, we strive to produce products that help our customers deliver on all of these production demands. One way we can achieve this is by using the adaptive software fixturing technology within PowerInspect to optimize the setup of parts for manufacturing processes. This radical approach to part setup reduces the need for complex and expensive work holding fixtures and replaces the traditional manual methods that are sometimes used to locate parts for machining. But it's not just the location of the part on the machine tool that is important. Some processes require an equal distribution of machining allowance within the available stock to produce a good part. The advanced alignment tools in PowerInspect allow us to optimize the setup for both geometrical features and complex 3D surfaces alike, giving us greater flexibility over a wide range of parts and materials. Using measured data acquired from the real part, we can accurately determine the true form and location of the part. Then compare it to the nominal form and location and use this data to determine the optimum setup for the machining operation. Measured data can be acquired from a wide variety of measuring devices, such as tactile articulated arms, non-contact scanning systems, coordinate measuring machines, and machining centres. In some cases, the data may tell us that a part cannot be manufactured within the design specification, as the part may have too much variation from the nominal form or location. This is particularly true where there is any form of heat treatment or pressure involved in the part manufacture. For example, fabrications, forgings, press-ins, and carbon fibre composites. Once the optimum setup has been determined, we can transfer the setup data either directly to the machine tool and run the nominal machining toolpath NC code, or we can transfer the data to the CAM software so that the machining toolpath can be re-exported using the optimized setup. Using PowerInspect, we can quickly identify parts that will not conform and ensure the machining process does not take place.
So I hope you understood the process. So this is adaptive software fixturing process. And why you should use adaptive software fixturing? So like I said before, it optimizes setup for every part. Dramatically, it will reduce your setup time. And there are a lot of benefits. It can minimize machining time. And through PowerInspect and PowerMill, you can do this joint activity. So through PowerInspect, you can generate the datum or delta, and it can be transferred to PowerMill for creation of the toolpath. So I have a small example. How adaptive software fixturing works. So in this case, if you see, so this die tool has been damaged. On the red color area, you can see this is the area on which customer deposits the material. Okay, this is the extra material. And what you can do inside PowerInspect. So suppose this component has to be remachined on the milling machine. So how PowerInspect will helpful for you? So you have to keep it on your machine, and roughly you have to align the component. Okay, so you don't need to go through very accurately. And once you align this component on the machine, on the same datum, you have to create the inspection sequence. Like here inside PowerInspect, you have to create the inspection sequence, and that inspection point can be exported through the NC program, and that NC program will be run on the machine, and machine will give you the measurement results, and that results has to be again imported inside PowerInspect, and it will be aligned through the best fit alignment. Okay, so we can compile with the best fit alignment. Then after creating the best fit alignment, your software will generate a new delta. So that new delta can be transferred to PowerMill. Okay, and on the basis of new datum, you can generate your NC program, and it can be the new NC program can be directly run on the machine. So this is the sequence for the tool and die repairing work. So another example of carbon fiber aerofoil. So if you are doing this kind of machining, so you don't need to invest on very costly fixturing works. So through this application, you can easily create a new datum or a delta. So it can be transferred to PowerMill for the milling work. So I hope you understood about this adaptive software fix process. So going through the summary, so what we covered in this session, so how OMV will be helpful for you and what are the process involving in PowerInspect. So how you can efficiently generate the probe sequence or probe toolpath and how to edit it, and what are the various methods for creating the probe path. Then we discuss about the adaptive software fixturing. So how it will it will increase your productivity and improve your setup accuracy. Okay, so these are the topics we covered this session. So now I am open for your queries. So if you have any kind of query, so please use your chat box, or you can ask me directly. So I will glad to answer you. So any questions, guys? Guys, so I'm waiting for your inputs here. Any queries or anything required to make you enable for promoting this OMB applications in your area. So I am open for your suggestions, open for your queries.